Okay, to obtain a good understanding of this combustion testing, we have to look at just a little chemistry. It's pretty simple. So here we have a fuel, and it's composed of carbon and hydrogen. And this fuel is methane, but oil is just a more complicated hydrocarbon, propane more complicated. And so what we're going to do is combine it with oxygen, and we're going to separate these molecules, okay? We're going to bust this oxygen apart and combine it with this carbon, and also combine it with the hydrogens here. And we're going to come up with the two products of complete combustion, which are carbon dioxide, CO2, and water vapor, H2O. What we're going to do is release some heat too. And the way we're going to look at whether there's a lot of heat being wasted is we're going to measure the flue gas temperature. The flue gas temperature could be anywhere, its spec could be anywhere between 100 degrees and 450 degrees, depending on the appliance. So you have to know what kind of appliance you have and what would be acceptable for that type of appliance, because the temperature of the flue gases, they could be too high, but they could also be too low. And if they're too low, they could cause condensation in the flue. And what we mean by that is this water vapor, instead of going out of the building as a vapor, could condense in the flue, and it's acidic, and it could rot the flue. So flue gas temperature is important, and we're measuring it with the combustion analyzer. And so the combustion analyzer is concerned with the products of combustion. And really, we would think that we want to measure CO2, and we used to measure CO2. But CO2 is directly related to the oxygen over here that went through the combustion process unreacted. Okay, so if we measure the oxygen, we can know what the CO2 is. But anymore, most of the combustion analyzers, they just measure oxygen. And so the oxygen is a good number for us. Oxygen and temperature are going to tell us how efficient the appliance is. And the oxygen could be all the way down to 2% on a very, very efficient, say, commercial boiler or something like that. And it could be all the way up to, say, 12%. And 12%, pretty much no matter what the appliance we're talking about, would be very inefficient. But you're going to find that kind of range, and that's going to tell you how much excess air there is. Well, what do we care about excess air? Well, we've got oxygen and nitrogen here, and why have I included nitrogen? Well, oxygen and nitrogen are the two components of the air. The air is 79% nitrogen, 21% oxygen. Every molecule of those two gases that goes through this process and ends up over here represents a kind of a waste, because every molecule carries some heat from the flame with it. When the gases leave the heat exchanger, some of the heat goes up the chimney, and the rest of the heat goes into the home. And that's what measuring combustion efficiency is all about. Combustion efficiency, or we also call it steady state efficiency. So in the safety part of the equation, we're looking for carbon monoxide. That's a red flag for us. And we measure it in the undiluted flue gases, but the undiluted flue gases still have some oxygen in it. And some people think that we need to calculate what the CO would be without any air, and that's the air-free CO. And so there's typically two different ways that you can measure oxygen. Doesn't matter to me, what way you measure them, but some programs and some standards say measure it, just read it as it was measured for an as measured value. And some standards say, no, we want it to be air-free. And you have kind of a spec that goes from all the way down to, 50 parts per million up to 200 parts per million would be acceptable under a lot of different standards. Where if it was air-free, it would be a larger measurement. And it would go from maybe, 100 parts per million all the way up to 400 parts per million. So pay attention to those standards, and whether you're looking for an air-free measurement or an as-measured measurement, and how to get those two measurements off of your combustion analyzer. And actually, the air-free measurement, as I said before, is not a measurement, it's a calculation. And it comes from the oxygen measurement and the CO measurement. Those two combine to get the air-free measurement. The way we calculate the efficiency is we combine the temperature of the flue gases with the oxygen, these two, and the combustion analyzer takes those two measurements and it calculates the steady state efficiency, which it will present to you in percentage. Here are the reactants. Here is the yield sign. Heat is released here. We get our products, CO2 and H2O. We're not measuring CO2, we're measuring oxygen, which is directly related. We could measure one or the other of these, but most of the analyzers measures oxygen. We calculate steady state efficiency. It also calculates the amount of excess air. Excess air in traditional appliances is usually around 50%, which means that we have 150% of what we need for ideal or perfect combustion. But we know it's not a perfect world yet, so we expect to have some excess air. But the more efficient appliances have less excess air than the traditional appliances. We have the molecules, kind of what they look like. You got the yield sign, the reactants are over here, the products are over here. That's about all you need to know about combustion analyzers to understand what they're measuring and what they're calculating.